You know, it's getting hard to ignore how much voice AI is just everywhere now.
Oh, definitely.
Talking to your smart speaker, dealing with those voice bots on customer service lines.
Yeah.
It's really becoming part of daily life.
Absolutely. And, well, they might seem pretty simple on the surface, right?
Yeah.
But there's actually a ton going on underneath to make them work, or sometimes not work quite as smoothly as we'd hope.
Exactly. And that's really what we want to dig into today.
Okay.
We've got some interesting sources lined up. There's an article that dives deep into the kind of hidden challenges of voice AI.
Mhm.
We also have a transcript from a YouTube video looking at AI voice agents and a presentation that lays out the basics of conversational AI.
Sounds like a good mix.
Yeah. So our mission here is to really pull out the key insights, figure out just how complex these systems are to build and keep running effectively.
And how people are tackling those challenges.
Right. So, okay, let's get started. Where's the logical first step?
Well, the very beginning of any voice interaction has to be the AI understanding what's actually being said.
Okay.
That's the job of automated speech recognition, or ASR.
Right, just turning our spoken words into something a computer can, process. Seems simple enough, but I guess it's not.
Not really, no. It's way more complicated than it sounds. The Teneo.ai article really highlights this. Even the best systems out there run into problems.
With what kind of things?
Well, just the sheer variety in how people talk. Think about accents, dialects.
Oh, yeah.
Even small speech differences, maybe impediments. Then you add background noise, people talking fast or slow, just pronouncing words differently.
Wow, okay. That's a lot to handle.
It really is. It's like trying to understand someone across a crowded room, basically.
Yeah, that's a good way to put it.
And some of the, let's say, earlier methods for ASR, like things using hidden Markov models.
HMs, right?
Yeah, HMs. They often needed this pre-processing step, MEL frequency substral coefficients, MFCCs.
Okay, what's that do?
It's basically a way to pull out the most important sound features from the voice signal to make it easier for the model to analyze.
Got it.
Then these systems try to figure out the most probable sequence of words based on, well, how they sound. That's the acoustic model, and how likely those words are to follow each other, which is the language model.
So it's like making a really educated guess.
Yeah.
Based on statistics.
Pretty much. But even then, you still get interpretation errors. They happen.
Technology's moving fast here, right?
Yeah.
Because the Teneo article, it mentions their Advanced Natural Language Understanding, NLU.
Yes, NLU. Different but related.
Right, NLU. They claim it adapts to different speech patterns and hits, like 99% accuracy, because it's trained on huge, diverse data sets. That sounds impressive.
It's a big claim, for sure. And training on diverse data is absolutely key. The more accents, speeds, and styles a system hears during training,
The better it gets.
the better it gets at handling stuff it hasn't heard before.
Good.
So yeah, 99% is ambitious, but it definitely shows the progress being made in making ASR more robust.
Okay, so let's say the ASR gets the words right. Step one. But just knowing the words isn't enough, is it? The AI needs to understand the meaning, especially in a back-and-forth conversation.
Exactly. That takes us right into the next big challenge, contextual understanding.
Right.
Voice AI can't just look at words in isolation. It needs to, follow the flow of the conversation. And the Teneo article points out that keeping track of that context, especially when a conversation goes on for a while with multiple turns, that's tough.
Oh, I've definitely felt that pain as a user. You're talking to an assistant, and it feels like it suddenly gets amnesia about what you just said.
Right.
It gives you some totally random response. It's so frustrating.
It really is, and that's why improvements in context management are so important. Teneo talks about how their system tracks previous turns to keep the conversation coherent.
Okay, how does that work conceptually?
Well, it connects nicely to something from the Sebi's presentation. They talk about using stories. Yeah, think of them as structured examples of typical conversations, like templates for how a chat might go.
Oh, okay.
These stories are used to train the part of the AI that manages the dialogue, teaching it to recognize common conversational paths and understand the flow.
So it's like giving the AI blueprints for different kinds of conversations, so it can guess what might come next based on what was just said.
Exactly that. By learning these patterns, the AI gets much better at holding onto the context and giving replies that actually make sense, which makes the whole experience less jarring for the user.
Makes sense. Okay, so
Yeah.
understood the words, got the context, mostly. But human language is still messy, isn't it? Nuances, jokes.
Which brings us nicely to natural language processing, or NLP.
Right, NLP, the core brain, sort of.
Very much. But as the Teneo article says, NLP often trips up on the subtle stuff.
Like what?
Things like sarcasm,
Well,
humor.
yeah, try explaining sarcasm to a computer.
Exactly. Or idiomatic expressions, phrases where the literal meaning is totally different from the intended one.
Break a leg, things like that.
Precisely. Plus, complex sentences or just long, rambling dialogues can also be challenging. That's partly why some interactions feel so robotic.
Right.
Teneo claims its NLP is better at handling these nuances, aiming for more human-like chats.
And how does NLP technically do that? The Sabi's presentation mentioned something here too, right?
It did. It talked about NLP models identifying intents and entities.
Intent and entities.
Intent is what the user is trying to do, like book a flight or check the weather.
Okay.
And entities are the key bits of information in what they said, like the destination city, the date, or the specific location for the weather.
Got it. So the AI tries to dissect our, often messy language into these structured pieces. What do they want, and what are the key details to figure out the meaning?
That's the core idea. The better the NLP engine, the better it is at navigating all that ambiguity and complexity in how we talk, leading to, hopefully, a smoother conversation.
Okay, that sequence makes sense. ASR for words, context management, then NLP for deeper meaning. But there's a huge elephant in the room here. Privacy.
A massive one, yeah.
We're feeding these things our voices, often talking about personal stuff. What about data privacy and security?
Yeah, that's absolutely critical. The Teneo article really emphasizes this point. Handling voice data, which can be very sensitive, raises big questions.
Yeah, done.
Companies need to deal with complex regulations like GDPR,
Right.
and they have to put really robust security measures in place to protect that user data. It's a major challenge, both legally and technically.
And it's not just about following the rules, is it? It's about trust. Users need to feel confident their data isn't being misused.
Absolutely fundamental. Teneo mentions things like being ISO 27001 certified, GDPR compliant, using encryption, controlling who gets access.
Standard security practices, but crucial here.
Essential for building that user trust and handling personal data responsibly. You just have to get it right.
Okay, so assuming you've navigated the privacy minefield, let's talk about making these AI systems actually useful in a business context. Integrating them must be tricky.
It often is, yeah. The Teneo article brings this up too. Connecting voice AI to existing business systems, think CRMs for customer info, or ERPs for managing resources.
Like Salesforce or SAP.
Exactly. Linking into those can be technically really complex.
Why is that?
Well, it usually needs specialized skills, developers who understand both the AI and the business system. Plus, it takes time and resources to make sure they talk to each other properly and data flows correctly.
So it's not just plug and play. There's a whole back-end integration job needed.
Very often, yes. Teneo talks about its integration capabilities, using flexible APIs, application programming interfaces.
APIs, right. The digital handshake between systems.
Exactly. Good APIs can make it much easier for the voice AI to connect and exchange data with those other crucial business apps.
All right, so we've covered understanding, context, meaning, privacy, integration. What about just how it feels to use the user experience? Designing for voice must be totally different from designing for a screen.
Oh, completely different world. The Teneo article highlights this as a specific challenge. You don't have visuals to guide the user.
Right, no buttons to click.
Everything has to work through voice commands, and the AI's responses need to be super clear, concise, relevant, but without just drowning the user in information. It's a tough balance.
Sounds like it needs to be much more conversational, less like navigating a computer menu.
Precisely. And that Design Lab article on VUI voice user interface best practices really nails this. It stresses simplifying interactions, making the commands feel natural.
Like their Domino's example.
Yeah.
Just saying, order my usual.
Perfect example. So simple, so intuitive. Teneo also mentions they provide tools and frameworks specifically to help design these kinds of user-friendly voice interfaces, ones that give you responses that make sense in the context.
Yeah, you want it to feel easy, almost effortless, right? Not like you're wrestling with a machine.
Exactly. And a big part of getting that smooth experience relies on the system not just being static, but constantly learning.
So it needs to get better over time.
Definitely. Voice AI can't just be built once and left alone.
Because language changes, people find new ways to ask things.
All the time. New slang, new products, new questions. The Teneo article points out that this continuous learning based on new data and how people are actually using it is vital.
That sounds resource intensive, constantly retraining.
It can be. You need the infrastructure and processes for ongoing training and updates. Teneo mentions their machine learning capabilities are designed to make these updates and retraining easier.
Okay.
And this ties directly back to another VUI best practice from the Design Lab article. Learning and evolving, using feedback, analyzing interactions.
To get more accurate, more personalized.
Exactly. It's this ongoing cycle: interaction, learning, improvement, interaction.
Got it. A constant feedback loop. So we've covered a lot of the core challenges. What about the underlying tech itself? Are there newer trends emerging in how these systems are actually built?
Yeah, absolutely. One major shift mentioned in the IJML article is the move towards neural networks for speech recognition.
Neural networks, okay, like AI brains.
Sort of, yeah. They're increasingly replacing older methods like those Gaussian mixture models or the hidden Markov models we touched on earlier.
Why the change?
They're just generally better at handling the sheer complexity and all the variations in human speech. They learn patterns more effectively.
So a smarter engine for the ASR part.
Essentially, yes. The IJML article lists a few types, like deep neural networks, DNNs, deep belief networks, DBNs, recurrent neural networks, RNNs.
Okay, alphabet soup. Any standout?
Well, RNNs are particularly good for sequential data like speech because they have a sort of memory. They can use what came earlier in the sentence to help predict what's next.
Ah, that sounds useful for conversation, like how predictive text works sometimes.
Similar principle, yes. And that IJML article notes that the big players, Google Home, Alexa, Siri, they all rely heavily on these neural network approaches, plus cloud computing power to do the heavy lifting.
Makes sense.
And thinking about those systems, the Design Lab article also points out important design practices we see, like handling errors gracefully.
Yeah, when it misunderstands you.
Right, like how Cortana tries to clarify, or providing clear feedback so you know it's listening or processing. And crucial things like accessibility series, type to Siri is a good example there.
It really is amazing how all these pieces have to fit together perfectly. The ASR, the NLU, the context, the design, the learning.
It's incredibly complex. We've walked through, 7 key challenges?
Let's see. ASR accuracy, contextual understanding, NLP limitations, data privacy, system integration, user experience design, and that continuous learning piece.
Yeah, that covers the main ones we discussed.
It really drives home that what feels like a simple, maybe even magical voice interaction has this immense iceberg of complexity underneath it. Building it, maintaining it, improving it.
Absolutely. And overcoming all those hurdles, using these advanced technologies, and really thinking through the design, that's what's needed to unlock what voice AI can really do.
Definitely. It makes you think, though, as this tech gets even more integrated into our lives beyond these technical challenges we've talked about, what other kinds of maybe ethical or practical questions might start coming up for you, the listener, as these artificial voices become even more common?
That's a really interesting thought to leave people with. What happens next?